Quadratic graphs have associated algebra that looks way more complicated than it is. There's really just two key features you're interested in when looking at a graph like this: the roots and the line of symmetry, or where the turning point is. First, the roots, where the graph crosses the x-axis. Usually for quadratics like this we can factorize if it's straightforward, but if not, you may be able to complete the square or use the quadratic equation if it does cross the x-axis. In this case, the factorization is quite simple and we can identify the roots at +1 and -3. And of course you can see these on the graph here, but you won't always have the graph visible. So the second feature you need to identify is the line of symmetry, focused on the turning point, the maximum or minimum of the graph, and minimum in this case. To find that, you need to complete the square, which I've laid out algebraically here, but it just simplifies to x plus or minus a number and then squared plus another number. And then the turning point will have coordinates minus p, q. For this graph, that's going to be half of 2, which is 1, square that and subtract it, and then subtract c there. The turning point has coordinates -1, -4, which you can see does match up with the graph.